Hi all, and welcome to the inaugural episode of Beyond the Breakthrough. I'm Kelsey Underwood, your host and digital communications specialist at AUI. During each episode, we'll speak with an expert who contributed to a scientific or technological breakthrough to explore how it came to fruition and its applications in the fields of STEM and beyond. We have a great lineup of scientists, technicians, and support staff for this season, and I'm so excited to introduce you to our first guests. Let's dive in.
As it turns out, in order to solve many of our climate change problems and our sustainability problems, some degree of mining, actually a large expansion of mining, is likely required. And so how we deal with those impacts in a way that gets to our climate and sustainability goals while not visiting those kinds of environmental impacts on lands, waters, air, and population that would otherwise be subjected to them is one of the grand challenges of the 21st century.
That's Adam Reed, a senior advisor in AUI's Energy and Environment Division. This week, I sat down with him and Tom Campbell, the co-founder and growth director of LEAP Manufacturing. LEAP is a consortium dedicated to accelerating the development and production of energy systems in the United States. Tom and Adam are key players in the Battery Technology Initiative Beacons, which stands for Batteries and Energy to Advance Commercialization and National Security. Funded by the United States Department of Defense, Beacon's primary goal is to assist in reshoring the manufacturing of lithium-ion batteries and to assist in the development of new capabilities in new battery chemistries, production, and workforce. Broadly speaking, there are three types of batteries: old-school lead-acid batteries, household batteries, and new-wave lithium-ion batteries. Focusing on the latter, Beacon's work will impact batteries for things such as electronic vehicles, laptops, and military drones. So where are lithium-ion batteries currently being manufactured? And why is Beacon's work to reshore the manufacturing of these batteries so crucial? According to a 2024 TrendForce report, China currently dominates the lithium-ion battery market, producing over 75% of the world's lithium batteries. China has this dominance due to a few factors, including control of raw materials, processing capacity, and heavy investment in battery factories. Due to the complexity of the United States' relationship with China, this current dominance poses challenges for the United States military and risk for national defense.
So there are, depending upon how you count them, within the Department of Defense, Office of Secretary of Defense, about 14 or 15 emerging critical disruptive technologies. So these are technologies that are critical to our national security as well as economic growth as a country. Energy storage systems is one of them.
The list of disruptive technologies that Tom is referring to are innovations that significantly change the way society operates. These technologies overturn the status quo, altering consumer behaviors, products, services, business operations, and even entire industries. Adam, who focuses on data analytics for critical materials on the Beacons project, describes the power of energy. No pun intended.
Energy is the commodity without which no other commodities exist. It is the lodestone for any modern economy, and it is the thing without which nothing else works.
Energy storage systems are the devices or groups of devices that hold power for later use. Energy can be stored in many forms, including kinetic, thermal, and chemical. Chemical batteries are what we're discussing here today. The most common lithium-based battery chemistries, of course, include lithium, but also cobalt, nickel, and graphite. Recently, though, chemistries have become increasingly more exotic, and obtaining many of these elements is no easy task.
Unfortunately, though, belie and make necessary the obtaining of some of these minerals, which are now called critical minerals, because they're not often very easily either mined and or processed or really even found around the country and in the world. So that is one of the challenges that Adam and team at AUI have been tackling, is to obtain knowledge about how you obtain these and get these materials readily available for the marketplace and the batteries themselves. One of the most exciting things actually that we're working on within Beacons is leveraging artificial intelligence to tease out wholly new materials and wholly new synthetic chemistries that maybe we've never even looked at before. There's a classic example, the Pacific Northwest National Lab, which we're working with or will be working with, has looked at 32 million different chemistries, and they boiled it down to about, I think it was the statistics, I got it down to about 50 in the simulations, and then they actually processed about 20 of those, and they found one or two, which looked super promising. There are about 4 or 5 elements in each one of these chemistries, but then they can robotically synthesize them and test them.
And whether mining elements for current or new battery chemistries, doing so in the United States and or its allied countries will present its own set of challenges.
But the United States gave up mining and processing of those materials because primarily of the NIMBY actions, the environmentalists, and then EPA constraints. China can do things that we don't want to generally do in the United States in terms of processing.
With these restrictions, how will future mining and processing be possible for the United States and its allies? Adam says the answer will be found in exploring and investing in new technologies that are both environmentally and culturally suitable for use in the Americas.
In order to solve many of our climate change problems and our sustainability problems, some degree of mining, actually a large expansion of mining, is likely required. And so how we deal with those impacts in a way that gets to our climate and sustainability goals while not visiting those kinds of environmental impacts on lands, waters, air, and population that would otherwise be subjected to them is one of the grand challenges of the 21st century.
Adam uses mining lithium carbonate, which comes from salt flat brines, to illustrate one potential step to overcome this challenge. To extract lithium carbonate, salt water is pumped from underwater reserves and placed into large fields to let the water separate. Then the lithium carbonate is moved through a series of ponds to further separation until it's usable. One of the primary environmental impacts of this extraction method is water pollution. If the underground brine water is overpumped, freshwater aquifers can be contaminated. However, new technologies show promise of reducing this risk.
Instead of pumping a whole bunch of water out of the ground and letting it sit in ponds, there are new technologies now being developed to directly extract lithium from the stream effectively. So as you pump brines out of an aquifer, for example, those can be passed through a membrane, which will separate out the lithium carbonate on site immediately, which means you get to avoid all of the large land disruption associated with traditional lithium brine extraction methods. And so investing in those new kinds of mining technologies, whether it's direct lithium extraction, seabed mining, asteroid mining, all of those things require they require investment and planning at a national scale in order to create those new technologies, which can make mining cleaner, which can make mining more efficient, and which will allow us to leapfrog ultimately the dominance that China has in traditional mining. China and Russia have in traditional mining technologies.
From the processing side, high energy usage causes air pollution. Traditional mining uses energy sources such as coal, natural gas, and petroleum products, which all increase pollution over time. While renewable energy is the cleanest method to power traditional mining methods, Adam says developments in recycling may help reduce emissions as well.
With advances in recycling, the hope is that we can create what's called a circular economy over a number of decades, wherein all of the materials that we need for batteries and for other things are ultimately recycled at the end of the product life cycle so that they can be reused over again. So the hope is not that we're going to end up having to build up a mining sector that continues extracting for the next 200 years, but that we build up a sector that does a lot of extraction over the next half century and then is able to sustain that without additional mining going forward.
Adam says the safety and well-being of communities and wildlife are also a component of cleaner mining practices.
It's also often the case that critical minerals are often co-located in places where there are sacred lands to indigenous peoples, where there are endangered species. And so finding extractive technologies that are minimally invasive is critical to being able to access those without causing damage to either sacred lands or important lands for national character, like national parks or national monuments. As well as ensuring that we're not harming or eliminating endangered species from the region.
Electrifying all 5 U.S. military units using clean, ethical methods will not only help to improve national security and the environment, but also conserve funds. As many of us know, filling up a vehicle's fuel tank is costly, and imagine the cost for filling tanks of an entire army.
I believe the DoD spends more money on gasoline and diesel fuel per day than any other group in the world. I mean, it's an unbelievable number.
According to the Department of Defense's fiscal year 2023 Energy and Fuel Budget Justification Report, the DoD consumed nearly 78 million barrels of fuel to power ships, aircrafts, combat vehicles, and contingency bases with a total cost of $7.9 billion. Efficiencies gained through electrification could significantly reduce the cost of energy while making the system less vulnerable and more resilient. Using batteries and enhancing these capabilities will aid with helping to improve efficiency and safety too.
As you may have seen in the Iraq and Afghanistan wars and now the current wars, that we tend to have all these convoy trucks of diesel fuel and fossil fuels, which get a lot of exposure on the trek to the warfighter out in the battlefield areas or wherever they might be positioned or stationed. And that is a high risk.
Additionally, lighter batteries would reduce the load on soldiers, who often carry packs between 68 and 120 pounds, according to an article from Boston University. With batteries typically making up a significant portion of weight in their packs, less weight would improve a soldier's performance and mobility. As for battery lifespan, a little bit of time can go a long way during a mission, which is a point of interest for Beacons and the Department of Defense, especially when it comes to fly times of drones.
If you have, say, 15 minutes only of more flight time, that's a big deal. You can go much further. You can be much more evasive if you're under attack.
Where would these new and improved batteries be manufactured? At facilities like the Beacons Battery Prototype and Commercialization Center at the University of Texas at Dallas. 15,000 square feet in total, the facility will have 3,500 square feet dedicated to a dry room for production. With a relative humidity of 1%, the space will ensure quality and reliability of liquid electrolyte batteries, such as lithium electrolyte batteries. In addition, the center will have a smaller room with just a 0.25% relative humidity dedicated to the manufacturing of solid-state batteries. Since this type of battery requires an utmost stable environment, special suits are required for those who enter the space.
Basically, that means if you as a human being walked into that room with no protection, your very body would increase the relative humidity itself. And so there'll be tight constraints about using that facility. But by reducing the relative humidity very low, we can do some amazing things.
How are these amazing things possible through Beacons? Tom says public-private partnerships are key, which for Beacons includes UT Dallas, the Department of Defense, Leap Manufacturing, AUI, and over a dozen additional subcontractors. Tom explains the importance of a collaborative environment.
You can spend a lot of money, but if you don't have the people to man it, it's kind of a pointless initiative. So you really need to have the people involved at the end of the day as well. But the public-private partnerships cover not just the university and the subcontractors, but also the startups, the defense primes, the national labs, other universities, the Department of Defense itself, other government agencies.
With public-private partnerships and big science rooted in the histories of both the United States and AUI, Adam has confidence the project team will succeed in making advancements toward Beacon's goals.
AUI was developed in 1946 in order to pursue exactly this kind of mission. And as with so many other things we invent, China has taken it and has ramped it up, and we've got to catch up.
That's a wrap on our conversation with Tom and Adam. A big thank you to both of them for sitting down with me to talk about the Beacons project. If you would like to learn even more about Beacons, you can visit their website at sites.utdallas.edu/beacons. And thanks to all of you, the listeners, for joining me for our very first episode. If you would like to be notified about new Beyond the Breakthrough episodes and special segments, be sure to subscribe wherever you listen and leave us a review while you're there to let us know how you're enjoying the podcast. Also, follow AUI on Instagram and X at DiscoverAUI and Associated Universities, Inc. on Facebook and LinkedIn to stay updated on all the latest breakthroughs at AUI. Thanks again for listening, and we'll see you next time.